Hello, this is Music Tech Help Guy, and welcome to episode 62 of my Logic Pro 10 video tutorial series. In this video, I'm going to give you just a basic introduction to compression and show you how a compressor can affect a kick drum. And the reason why I'm just using a kick drum for this is it would take far too long for me to explain how a compressor works, and then also show you what settings I use for certain instruments. So in this video, I'm more or less going to just give you an overview of how everything works and how to understand and work with compression. And then in the next video, I'll show you what settings I actually use for certain instruments. So the plugins I'm using today are the Logic's just stock compressor plugin. It's a great compressor, especially for a stock plugin. And I'm also using iZotope's Nectar breath control plugin. I'm not actually using this for the breath control. I'm actually just using it just to get a real-time waveform display up here. So you don't need this. This is just something I'm using as a tool to sort of show you, what's going on up here and show you how the waveform is changed by the compressor. So first I should explain what compression is. Compression is a form of dynamic processing, which means we're affecting the volume of the signal in some way. And it's not just simply increasing or decreasing volume. With dynamics plugins, typically you can affect the volume of a signal differently at different points in time. So do you want the transient to be a little poppier, a little punchier, and then the the release of the waveform to be a little, ducked down, a little bit softer? Or do you want the opposite? Do you want the release to be really, big and boomy and the transient to sort of be ducked down? So dynamics plugins allow you to affect the volume of an audio signal across time. With compression, there's basically two forms of compression. There's downward compressors and upward compressors. Upward compressors are often called expanders, and so we might talk about that in a future video. So for today, the compressor plugin, we're basically just working with a downward compressor. So essentially what our compressor does is it can push down the audio signal of a waveform, but then let through transient material. So what ends up happening is you push down the overall volume, let some of the transients through, or let less or more of the transients through, and then you can, because we've pushed it, sort of like the overall volume down, we can actually add output gain to that. We can add sort of upward gain to that. And actually, even though we compress the signal to make it quieter, we can then add gain to it to make it sound louder, to make it seem louder, seem more present, and sort of pop out in the mix better. Again, this is one of the reasons why I'm using a kick drum as an example. Is kick drums have, a kick drum has a more transient material. It's not like we're working with vocals, which sort of, the transients are varied from word to word. So okay, so let's jump into the compressor plugin. First, to start, I want to set the compressor basically back to zero, to no compression. So there's a few things you're going to want to do if you're working along with me. First, I'm going to make the circuit type platinum. I'm going to turn the ratio down to 1:1, which basically means we have no compression. The knee I'm going to pull down to 0. The threshold I'm going to pull all the way up, and the gain I'm going to put at 0 dB. And then the auto gain I'm going to put on off, and then I'm going to put this on peak, not RMS. The attack and release aren't going to matter since our ratio is at 1:1. So basically, the difference between my compressor on and off right now is nothing. If I turn the compressor off, this is what the kick drum sounds like. With the compressor on, this is what it sounds like. So it's basically identical. So the first two elements of a compressor that you should understand are the ratio and the threshold, the compression threshold. So the ratio is how much gain reduction are you applying to the input signal. So if I put this at roughly 4:1, it's 4.1 to 1, but 4:1. Basically what that means is if I have a transient, let's say I have part of my kick drum that exceeds the threshold value by 4 decibels, let's say that. if it exceeds the threshold by 4 decibels, what's going to happen is that 4 decibel transient is going to be lowered down to a 1 decibel transient. So everything that goes above the threshold is going to be reduced down by a factor that is determined by the ratio. So the higher the ratio, the more compression you get. The lower the ratio, the less compression you get, the softer compression you get. So if I put this at, say, let's say 10 to 1, or roughly 10 to 1, there we go, 10 to 1. This means that the output signal is going to be 10 times, well, maybe not 10 times lower, but at a ratio 10 times lower than what the input signal was. So we're going to get something that's a transient that goes above the threshold much quieter than the actual input signal was. Now you have to be careful with this, because if you compress things too much, it can sound woofy, kind of boomy, and kind of nasty sounding. So there will be some different ratio settings that I use on different instruments in the next video. For now, I'm going to set this to roughly 6 to 1, 6.1 to 1. Now, our compression threshold right now is all the way up. So we want to pull this down, and the lower the compression threshold, the more the threshold is sort of eating into the actual waveform sound. So as I pull the threshold down and pull the ratio up, I'm going to get a more boomy, more compressed signal. As I pull this up and pull the ratio down, I'm going to get a sort of a softer compression. So let me just start with the compressor threshold all the way up, and I'll slowly pull it down while this is playing, and watch how this sort of transforms the waveform up here. So as I pull the threshold down and the ratio up, we're going to see the signal get lower and lower and lower, because we're attenuating the signal. We're lowering the gain on the signal. You'll also notice that when this is and it's up, the threshold was sort of in the upper values. The gain reduction meter here wasn't doing anything. So it basically meant that there was no compression because the transient wasn't reaching the threshold. So as you pull this down, the transient in the kick drum starts to reach the threshold, starts to surpass the threshold, and then it has to be compressed by a ratio of 6 to 1. And so that's what that gain reduction meter is showing us. It's showing us how many decibels of attenuation do we have for each kick hit. So the further this is down, the more gain reduction we're going to have. The further up this is, the less. So I'm going to put this down here just a bit. Let's say 15 decibels, negative 15. And we're getting roughly between 3 and 4 dB of attenuation. Now, the thing is, when you pull the gain down, you pull the ratio up, you are essentially just lowering, you're lowering the volume at certain points in the waveform. Not at all points in the waveform. You're lowering the volume at just sort of like the high points in the waveform, at the transient points in the waveform. So what we can do is, because we've got a quieter signal now, is we can boost that signal back up. So if I hit play here, you'll notice that on the meter here, we have 12 decibels of headroom to work with. So we can actually boost the gain up. This is sort of the output gain. We can boost the gain up to, it's often called makeup gain, to make up for that 12 decibel loss that we're seeing there. So on 0, I'm actually able to boost this up by 14 dB and still not clip, because we've sort of lowered the transients, kept sort of the tone of the drum, and then pushed everything up. So this is why compressors, even though they actually push down your audio signal, this is why you're able to sort of push it back up, and people describe compressors as making things louder, and that's because of the makeup gain. Now I don't want quite that much makeup gain. I'll pull up to say 8 and we'll just leave it there. All right, next let's talk about the attack and the release time. There's a misconception that attack means how much attack do you have, how punchy is this. It's totally not true. The attack time has to do with how much of the transient is let through at sort of the front end of each kick hit. So if I have a really low attack time, what's going to happen is we're not going to see so much of this sort of high-end energy here. We're going to see a really short little blip of energy, you know, a short little sliver of a transient coming through. As you increase the attack time, it lets more and more of the transient through. So you'll have a more natural sounding transient. But sometimes when you have a shorter transient, it can make the front end of words or the front end of a note a bit more choppy, a bit more punchy. So just by hearing a bit of a shorter transient rather than a longer transient. So what I'm going to do is I'm going to pull this attack time down to 0 milliseconds, and I'm going to pull it up, and you'll be able to slowly just observe the difference in the waveform and how this affects it. So let's start at 0. Actually, I tell you what, let me pull the threshold down a bit more and the gain up a bit more, just so we really exaggerate this. I'm going to pull the ratio up a bit more to just, again, to sort of exaggerate all this. So you can see there with a really short attack, we're just letting a very quick little blip, little sliver of a transient through. So it's creating a really hard pop on the signal. So if I pull this up, we're going to let a bit more of that transient through. It's a bit poppier now, a bit punchier, which we might want for a kick drum, especially if this were, say, an acoustic kick. But it's not completely unnatural like having a really super low attack time. By the way, this compressor plugin goes into the milliseconds, but there are compressors out there that go into the microseconds, so that you sort of really fine-tune the attack time. So if I pull this up even more, this sort of short, punchy transient is going to get longer and longer. And then at its highest value, we're letting 200 milliseconds of the transient through. So I don't really want that much, so I'm going to put it toward the middle here. Yeah, I want to let some of the transient through, but I do want to get a nice sharp little punch on that little bit of poppiness to it. All right, the release time is essentially how long the compressor holds on to the signal. It's a bit confusing to understand, but it's easier to understand if you just sort of look at what their gain reduction meter is doing. When the release time is really low, the gain reduction meter sort of lets go of the signal, doesn't reduce the signal as long. And as you pull the release up, the gain reduction lasts for longer. So it's not like there's like one particular setting that's going to work for certain instruments. It's more or less just using your ears. And the same thing goes for attack time. Use your ears, and what sounds the best is probably the best. There's not like a set setting you're going to go with every single instrument, because depending on the preamp and the mic and the distance of the mic and the instrument, you're going to have a different, and the application and the genre even, there's going to be a different sort of way to compress each instrument. So with release time all the way down, you'll see that the gain reduction only lasts for a very short amount of time. As I pull this up, the gain reduction is going to last for even longer. So because the gain reduction is lasting longer, the sort of tail end of the transient is being ducked down further. the tail end of each kick is being ducked down further, compressed down further for a longer amount of time. So you get less of a boomy sound and more of a punchy, sort of clean sound. As you pull up or pull down the release, you're going to get more of a boomy sound because the signal is being let go quicker, and sort of the natural boom and the natural tail of the transient, the tail of the waveform is coming through. Now, with release time, you want to be careful not to pull it all the way up, because all the way up is 5,000 milliseconds. That's 5 seconds. If you pull your release time up so high that it can actually, if you pull it up too high, the release time can actually bleed into the next note, and so we can have a release time that kind of blurs the transient on the next drum hit. So you have to be careful about using a release time that's too high, because you'll end up with something like this, where that nice punch that we got from having our 62 millisecond attack is gone because the release time is actually bleeding over into the next drum hit. So you just have to be careful about using extreme high release times. So I think about 460 sounds okay. There's also an auto button, and what this does is it automatically adjusts the release time based on the material, which is kind of cool. You will notice that the release time does still change in auto mode. It just sort of works around the range of where you set it. So I'm going to set this to about 400. It's like 390 that it works, and I'll turn the auto function on. There we go. Now, next, let's talk about knee. You can either have a hard knee, which is down at sort of 0 or closer to 0, or a soft knee, which is closer up to 1. What a compressor knee does is it determines how material how the signal is treated as it approaches the compression threshold. So if we go with a soft knee, you'll see that the diagram here gives us sort of like a rounded edge. And what that's basically showing us is that as transient material, or as the signal creeps up closer and closer to the threshold, it will be variably compressed. So what this means is that signals that are just about to hit the threshold or just slightly over the threshold are actually going to be compressed at a lower ratio than those signals that are really higher or very higher or a little bit higher above the threshold. So what this actually means is if you pull the knee all the way soft, it actually means that softer signals can actually be compressed less than louder signals, and louder signals can be compressed more than softer signals. I usually use a soft knee on anytime I want the signal to be sort of organic and sort of just to sound a little bit more natural. Things like acoustic guitar, vocals, synths, strings, things like that. I usually use a hard knee for like things like drums, where I want dynamic sort of regularity. With a hard knee with a lower value here, basically all values going all the way up to the threshold are not going to be compressed. And as soon as the signal, goes over the threshold, it's going to be basically compressed the same as any other signal exceeding the threshold. So you get a bit more dynamic regularity, but you lose sort of like the organic element to like acoustic instruments and the voice. So if all else fails, stick the knee in the middle, and it usually will sound fine. And again, use your ears. If something sounds better with a hard knee or better with a soft knee, go with it. Your ears are your best tool. All right, you also have, there's 2 buttons down here for peak and RMS. Now, if you don't see peak and RMS, if you just see, I believe it's just RMS, it's probably because you have your circuit type set to something other than platinum. So we'll talk about these circuit types in just a moment, but for now I'm going to set the circuit type to platinum. And on platinum, you can choose between a peak or RMS detection method. And basically what this means is, does the compressor threshold detect the threshold based on the peak of the waveform going above the threshold, or does it so basically the maximum value, the maximum volume, or does it detect it based on the average volume, which is the RMS. RMS stands for root mean squared. In just very generic terms, it basically means it's the average overall power of the sound. So what this means aesthetically is it means that if you compress the signal and you set the if you set this to peak mode, you're not really going to have any clipping issues unless, of course, you crank the gain up too high. With RMS, you can actually the transients can actually go above the threshold because it's actually detecting the average overall volume rather than just the peak volume. And again, aesthetically, this is really what I'm more concerned about and what you're probably more concerned about. I tend to use peak mode for heavy transient material, so drums. I tend to use it for things like sort of like chunky, percussive sounding like guitar, like reggae guitar, or just like sort of chucky guitar. RMS I use on things like vocals and anything that's just sort of not as transient heavy, and it tends to work out best for me that way. So I'm going to keep this on peak, but when we go over to the other circuits, we're going to be forced to basically it doesn't allow us to choose between the two. I believe with the others it uses RMS is actually the sort of the standard value, even though it doesn't say that. All right, and then the last thing I need to go over in sort of the compression area, other than the circuit types, is the auto gain. The auto gain will actually add volume automatically back to your signal to sort of automatically make up gain for the threshold. So you can set this to off 0 dB or negative 12 dB. On off, and the best way to sort of experiment with this is to put the gain at 0, the makeup gain at 0, and then look at your fader and see what the headroom is. So my compression threshold set to negative 21, ratio is at 13, auto gain is at off. I'm going to put this on peak, and let's hit play. And you'll see I've got quite a bit of headroom to work with there. If I set the auto gain to negative 12, I'm going to get a bit of automatic gain, but not quite as much as if I set it on 0 dB. So now I've got quite a bit less headroom to work with. And if I set this on 0, it's probably going to clip. Yeah, now we're clipping because it's added too much gain to the signal. So generally, I actually keep this on off. I like to add the gain manually myself because you'll find if you're on 0 or negative 12, sometimes you'll find yourself pulling the gain, makeup gain actually down. And I would just prefer keep this off and just sort of add the gain in myself, because I like, one of the general rules of mixing is not to let things clip, So I don't want to let my kick drum clip, so I just basically set the gain to 0, hit play, and then bump up the gain until the kick sort of approaches, the orange, but doesn't quite hit the red. Hang on here, just one moment. There we go. I accidentally pressed undo, and I brought back a previous track I had in here. But let me just do that again. So yeah, I'm just gonna set this gain to 0, and then bump the gain up until I'm sort of in the orange. So I'm sort of hitting the orange, just barely hitting the orange without going into without clipping. All right, next let's talk about the circuit types. You basically have 6 different circuit types. You have Platinum, Studio VCA, Studio FET, Vintage VCA, Vintage FET, and Opto. And basically what these do is they just emulate different circuit types in analog compressors. Platinum is basically just a digital compressor. It's very clean. It doesn't colorize the tone much. Sometimes that's good. Sometimes that's not good. Sometimes you want the coloration of a VCA or a FET or an Opto. The VCA types are, that VCA stands for voltage controlled amplifier, and VCAs are variable gain amplifiers, which basically means that you can attenuate the signal and you can also boost the signal. So the circuit itself has the ability to both increase and decrease the signal. FETs, FET stands for field effect transistor. A FET is essentially a variable resistance amplifier. So that means that the FET itself can't boost the signal. It can only attenuate the signal, and then you'd have to have something else in line with the circuit to boost the signal, like an amplifier or a tube to boost the signal. With opto stands for optical. An optical compressor, the basic premise behind it is that it changes electricity, so like your audio signal, into light and then back to electricity again. And there's a certain tone coloration that you get along with that. Without really getting into the science of all of these, and frankly, my own knowledge is limited about these. I just sort of know what they sound like, and really each one's going to sound different for each instrument. So it's not a matter of really fully understanding the sort of the circuitry behind these circuit emulations. It's rather which one sounds best for what particular application. And we'll get into some of that in the next video, but just to sort of show you what they sound like, I'm just going to sort of cycle between them. So there you go. The platinum is the most perfect. It sounds perfect, but sometimes perfection is not always what you're going for in the audio world. Sometimes coloration is what you're going for. So in general, VCA circuits tend to be a little bit slower. The attack time tends to be a little bit slower. They tend to sort of sludge through the signal a bit more. It's not necessarily a bad thing. VCAs work real nice for vocals, on more organic instruments that you don't really need a whole lot of pop to. FETs tend to, and I'm really generalizing here, by the way, FETs tend to treat the signal a little bit faster, a little bit, and tend to be a little bit punchier, so they tend to work a little bit better for like drums and heavy transient material. Optos can really work for anything. They work well for vocals. They work well for really anything. It's just a matter of how you set up the compressor. The other thing to keep in mind is some of the vintage settings. The vintage ones tend to color the signal a bit more than the studio ones and the platinum circuit does, because older gear didn't always, vintage gear doesn't always have the most high-end parts in them. Sometimes they're built with what we would consider by today antiquated technology. But sometimes it's the imperfections caused by that antiquated technology that actually gives it the tone we're looking for. Like, I really liked the sound of the opto on that kick drum. It colorized it more so than the other four. The VCAs colorized it a bit more than the FETs did. The FETs tend to be a little bit poppier. So, depending on what application this is for, whether this is acoustic kick or an electric kick, or this is heavy metal versus folk or blues or jazz, you can get a different tone out of your kick drum, or out of any instrument for that matter, that kind of matches the sort of vibe that you're going for. So I can't really say that one is better for one application or another, but that's just sort of a very generalized opinion of what they can be used for. Now, lastly, there is a limiter. Like I said before, the compressor in Logic is a compressor and limiter. So everything from here over is all compression. From here to the right is just limiting. So you just turn the limiter on just by clicking here. And what you do is you pull the threshold down. It's basically the maximum volume that the fader is going to, or the meter is going to sit at after the compression. So if you find that you're still getting, let me put this in Studio FET for a moment. If you find that you're still getting, if you're getting clipping, if you turn the limiter off, you'll see it's actually going to clip really heavily. You can turn the limiter on. I usually set it to negative 0.1 dB because sometimes it'll still clip at 0. And then it'll keep the channel strip from clipping at that on this plugin. Now, you have to be careful with this because when you turn a limiter on a signal that's like clipping, like majorly clipping, like I was before, you can actually change the tone of the output, and that's not always desired. You know, sometimes that's a bad thing. Sometimes if you're going for an intentional distortion effect, sometimes that can work. So I usually just keep this on, and but I try to keep the gain at a reasonable level. So that the track is not clipping even without the limiter. And if it is clipping, it's barely clipping, and then the limiter just sort of takes care of the clipping. And this all goes back to what I was saying in the earlier videos, that your best bet is to not overdo volume, mix at a low level. And then if you're worried about the mix being loud later, add the volume later in mastering, because it's really easy to do there. If you mix really loud now, you're going to have trouble with clarity and you're going to have trouble with balance while you're mixing. So at least make the mix sound good at a low level, and then you can add volume to it later. Okay, there are some other controls in the compressor, like the sidechain options. There's also some additional options down here, like the output mix and the output distortion. We'll go over some of these in a future video. And in the next video, I'll jump into compressing drums. Then I'll jump into compressing vocals and guitar and bass. And I'll apply some of these things that we sort of learned in this video into my actual session. So I hope you enjoyed the video, and thanks for watching.